Welcome back to the GCSE Maths Pro YouTube channel. In this video, we will be going through some of Venn diagrams, but more specifically, the ones that are normally 3 parts and we're given some kind of context. So what I mean by that is the ones where you've been given a context, like in this case, a pet shop owner asks 50 customers whether they have a dog, a cat, or a hamster. And then you're given this kind of list of numbers of information and that you have to complete the Venn diagrams. So we know that we've got 50 customers in total. That means that the whole Venn diagram has to add up to 50. Then we've been told that of these customers, 3 have all 3 pets. Okay, that's obviously then the middle. So let's fill that out straight away. 5 do not have any dogs, cats, or hamsters. So that's none of the bubbles. That's just 5 on the outside. And you can kind of tick them off as you go along. 12 have both a dog and a cat, but not a hamster. So that would be in the overlap between dogs and cats, but not including the 3 that are down here with a hamster as well. So that is just 12 as it is in that overlap of just dogs and cats. Now that's a key thing to note because then the next line says 6 have a cat and a hamster. You might think that that's therefore here. But it's not. Just pause for a second, this happens quite a lot. If they've mentioned that you've got 2 of the categories and they haven't said but not the 3rd one, then that means that we're actually referring to this overlap here between cats and hamsters. But they haven't said that out of those 6 they also don't have a dog. They haven't said that, have they? They've just said that they have a cat and a hamster. They could also have a dog. So just be aware of when you're reading it, if I just rub out this line previously, do you see how the previous one said they have a dog, a cat, but specifically not a hamster, which is why it was this top part here. The next one just said cat and hamster. It didn't say, but not a dog. So just be really careful when you've got these 3-part Venn diagrams. Have they said that they have 2 of the categories, but not the 3rd, or have they just said that they've got 2? So what we're saying here is that 6 represents this whole overlap here. Now, if we've already got 3 in kind of half of that overlap, then this other missing part would be the other 3. So that there is 3. Then we've got 30 in total have a dog. So that means the whole bubble for dog. So all of this, there's 4 categories here. We already know 2 of them, so that adds up to 15. We're then missing the other 2. So as it stands, I can't really do anything with that information because I don't know with what's left, which is another 15, whether it would be in just dog or just dog and hamster. I don't know that yet. So let's just leave that one there for now and then check out the last piece of information. So it says all 10 who have hamsters, so out of the hamster bubble, all 10 of them also have either a dog or a cat. Now what that tells me is that no one has just a hamster on its own. They all have at least another pet as well. So that then tells me that the 10 represents these 3 parts here. So do you see how I can use that information to work out the missing part here, which we would put as 4, because obviously 4 plus 3 plus 3 makes 10. Now that I know that, I can come back to the fact that the whole dog bubble must be 30. So if I've got 4 plus 3 plus 12, that makes 19. If it has to add up to 30, then that means that this bit here is just 11. Okay, so now I've dealt with all the information they've given me, but just be careful because there is technically one other section that we haven't filled in. And we haven't really used the information about there being 50 customers. So what we can do is add up all of these numbers that I do have, check what the total is, and then whatever's left between that and 50 should be the cats only section. So you can see here that this adds up to 38, which means that if I take away that from 50, I have 12 left. So there's 12 for just cats. So do make sure that you filled out every single section as well and that you haven't missed anything out. Obviously, if you end up adding all of this together and you get more than 50, you know that something has gone wrong, and it is likely to be this section here about whether they've got 2 of the categories and not the 3rd, or just 2 of the categories in general. That is a key piece of information to pay attention to. So that was part A to complete the Venn diagram. Often there will also be a part B. So for our part B, I have just copied it down here, the same Venn diagram. We've got that one of the customers is chosen at random. So one of the 50. So out of the whole Venn diagram, one of the 50 is chosen at random. Given that this customer has a dog, find the probability that this customer also has a hamster. Okay, so if we've picked one out of our Venn diagram, they've guaranteed that this person does have a dog. So actually we're narrowing it down now and we're just looking at this dog bubble here. So it's no longer the whole 50. They've said given that they have a dog. So they already have a dog. So I've picked technically one of the people out of this dog bubble. Find the probability that this customer also has a hamster. So out of this bubble, which ones have hamsters here? They haven't said that they don't have a cat either, have they? So it does also include the 3 in the middle. They might also have all 3 of them. So I'm looking at this. Obviously, it's a probability. I'm probably going to give it as a fraction, so I need 2 numbers. So you see the 2 things I've circled there. The people that have a dog and a hamster are these 2 in the pink bit. As I said, it doesn't really matter if they have a cat or not. They haven't said anything as to whether it has to have a cat or not have a cat. So I'm going to include both. So that's 7 people, isn't it? 7 customers. But because they've said the fact that it's given, it's already happened that the person has a dog, I'm only counting out of the whole dog bubble, which we know is 30, or if you add it up, it should give you 30. So it's not out of the 50, it's out of the 30, because of the fact it says given. If it just said, find the probability that a customer has a hamster, then yeah, it would be the whole hamster bubble out of the whole of the Venn diagram, wouldn't it, the 50? But because they've said, given that this customer has a dog, so they already have a dog, so we're guaranteeing that we've picked someone from these 30 here. Out of that 30, how many also have a hamster is then 7 out of the 30, isn't it? So just be really careful with the part B. Are they referring to the whole Venn diagram, or have they given you kind of like a given that statement where they've narrowed it down? So 7 out of 30 for that one. Okay, so as you can see, our next question is very similar. We've still been given some kind of context. We've been given a list of pieces of information about the scenario, but we've got 2 differences. One, we've not been given a Venn diagram initially. Obviously, because the video is on Venn diagrams, you kind of know that's what we're going to do. But you could get a question in your exam where you get this kind of setup. They haven't actually hinted or mentioned Venn diagrams at all. And you would just have to kind of think, yeah, do you know what, in this scenario, I think it's easier if I draw my own Venn diagram. That's fine. And the second one, as you can see in terms of the question, is just straight into a work out the probability scenario. So it's effectively like the previous question where we had part A, complete the Venn diagram, and then part B, work out probability. It's basically those 2 just put into one question. So the number of marks is probably the same, it's just been put into one question rather than split into 2 parts. So for this one, I would just recognise this and go, do you know what, we've got 3 subjects, I'm probably going to make a Venn diagram out of it. So I would personally draw my own. So I've obviously got one here, but you can just kind of sketch one out as long as they can read it well, that's fine. So the scenario we have is that 60 students were asked if they study maths or chemistry or ICT. So you can see maths, chemistry, ICT, and then the list of information. So let's just fill out this Venn diagram first and we'll worry about the probability at the end. So 39 study chemistry, so that's the whole of the chemistry bubble, which means I can't really write that down yet because I don't know how that 39 would be split into the 4 sections. So let's just pause on that first piece of information. The next one is 14 study maths, chemistry and ICT, so all 3. So that's a nice easy one, that one can go right in the middle. Then we've got 19 study chemistry and ICT. Now remember what I mentioned about the previous question. Just because it says chemistry and ICT doesn't mean that it's this bit here, because that section there is chemistry and ICT but not maths. Now it doesn't say anything about them not studying maths, does it? It just says chemistry and ICT. So just remember that. Therefore that means the 2 sections here, this whole overlap do you see between chemistry and ICT. Now we already know the 14, so do you see how I could work out the chemistry and ICT on their own without maths would be the difference. So 19 take away 14 is just 5. So just make sure you read it really carefully. So that's 5. If it doesn't mention not a 3rd category, then it means the overlap between them both fully. Now you can see obviously then the other version here is 8 study maths and chemistry, but not ICT. So that's then them saying maths and chemistry, but not ICT. So now I know that it is just 8 that will go into this section here, and I don't need to find any differences. So that's 8. So just be careful with the difference between these 2 types of sentences. Then we've got 3 do not study any of the subjects, so 3 obviously goes on the outside. And then all 32 students who study maths, so that's the bubble for maths, is 32, also study at least one other subject. So that means that there is no one who only studies maths, and that these 3 here have to add up to 32. So you can obviously work out that there should be 10 that only study maths and ICT. So that's 10 here. Now, coming back to the one that we missed was obviously the 39 study chemistry. I now know the other 3 sections, so I could work out what's missing for just chemistry. And you can see that there's 12 who only study chemistry. So now we've done everything on that list, but also don't forget that we haven't used the total, which is 60, because we're also missing how many just study ICT. And don't forget to include, obviously, the 3 on the outside. You can see here that there are 8 left. So there are only 8 that study just ICT. Now all of the sections of my Venn diagram are complete. I can now actually focus on the probability. So we've got here 2 of the 60 students are chosen at random. Okay, so out of the whole Venn diagram, 2 of them are chosen. Work out the probability that they both only study ICT. So we're focusing on the ICT bubble here. So this is slightly different to the previous probability question that we had. There's no given that. We are saying that it's out of the whole Venn diagram, so our denominator is going to be the 60. But the difference is we now have 2 students. So it's kind of like in my head, when there's 2 events, so it could be throwing a coin twice, it could be rolling a dice twice, it could be playing 2 games, picking 2 students. That, in my head, the layout is like a probability tree, isn't it? So you've got the kind of, you don't have to draw this, but just to show you, this is like student number 1, and then student number 2, or I guess there's 3 options, isn't there? 3 options. Student number 1, student number 2. So you don't have to draw a probability tree, but it's just to kind of explain it that way. I'm going to first work out the probability of my first student. So what's the probability that if I've got all 60 students just stood in front of me, what's the probability that the person that I pick does study ICT? Well, how many actually studied ICT, first of all? If I add this up, I get 37. So the probability of choosing ICT is 37 out of 60. But this is where it gets tricky because there are 2 of them, 2 students. Now, some people might just multiply this by 2. That wouldn't work because you'd end up with a number bigger than 1. And remember that all probabilities add up to 1, or should be less than 1, shouldn't they? You can't have more than 1. You can't have more than 100% chance, can you? So you can't double this. So that's why I like to mention the probability tree, because how does a probability tree work? Let's just draw part of it. Let's say that's student number 1. We're obviously wanting to focus on ICT. That probability is 37 out of 60, isn't it? And then we want to choose for student number 2, ICT again. So you don't have to draw out the whole tree. You can just see the branches that I want is ICT for student 1 and ICT for student 2. But what is the probability of ICT for student 2? Because when you're picking 2 students, it's kind of like saying, okay, I picked 1 student. Let's just say that that student came and stood beside me. That means that the people that are left, because I'm not replacing the student, there's no mention here that they've replaced the first student, right? You've picked 1 student, you've then picked another student immediately. So there's no replacement. So think about it like that. First of all, in front of me, there's now only 59 students left because one of them I chose was next to me. But if I already chose student number 1 who does study ICT, then the amount of ICT students left in front of me is now 36, isn't it? And then think, how do I work out probability trees? You know, we highlight the branches that we want to use, and we multiply between the branches because we're saying ICT and ICT. And the AND rule is multiply, isn't it? So the probability of getting 2 times ICT is multiplying the 2 probabilities together, but they are different probabilities. So yes, this is a much more advanced question. And you can obviously just leave it as a fraction. So I get 111 over 295, which you can see is obviously less than 1, as it should be. So 111 over 295 would be your answer. So this would probably be minimum 5 marks, if not 6 marks for all of this work. The Venn diagram and then the probability. If you do want to recap on how probability trees work, then I will link that video down in the description as well, just so that you know that you can combine the logic of probability trees to help you figure out how to work out this question as well. As I said, you don't have to draw this out, it's just there to kind of be a visual, because imagine that that was maths and this was chemistry. Obviously the tree would carry on, but we were only focusing on the branches for picking both ICT students. So thanks for watching this video. If you found it helpful, make sure to like and subscribe. Our next video on Venn diagrams is specifically on set notation. So not with the context of actual numbers or scenarios. This is now in terms of set notation with intersection, union, all of that kind of thing.